Okay, welcome everybody to Friday afternoon. Please welcome to the stage Object Storage, Vladi. Thank you.
Thank you, everyone, and welcome to my presentation about object storage in CloudStack. Okay, here is the agenda for today. We'll start with explaining a little bit about different storage types. Then we're gonna make a short introduction into object storage in particular, and the way it has been implemented in CloudStack. And we will show a little bit, explain about the UI browser you created as additional feature. And of course, we'll see how it works in real life and in our demo. But first, a few words about me. I live in Sofia, Bulgaria, and I have two boys. I have more than 20 years already as a QA experience in different fields and areas. And I'm using CloudStack for the last 4 years on a daily basis, working as a software engineering test in ShapeBlue. And also I'm open source enthusiast, so I try to use as much as possible open source software whenever I can. That's the reason this presentation is made in Impress, running on Ubuntu desktop. Okay, different storage types. Probably most of you know about this, but let's repeat again. We have block storages, which is probably the most common type. So it divides the data into equal-sized blocks. Typical examples are Sun, iSCSI, and local disks. And we have file storages. They use network shared file system. Again, NFS and Samba servers are the most used of this type. And finally, our today's topic about the object storage. So this is the architecture that works with data as a distinctive units known as objects, and probably every big cloud provider has its own implementation, which is S3 for Amazon, Azure Blob, Google Cloud, etc. Here we have a small diagram of different types, and it's their usage according to application and user needs. You can see the some applications using block storage running on fiber channel and iSCSI interface, which are directly connected, not via network. And then we have network attached storage systems like NFS and Samba, and they are running through the network. And finally, we have the object storage. They run on REST interface, and yeah, that's it about that. More about object storage. This is the primary storage used in cloud computing nowadays, and every object contains the actual data. It contains metadata. That is the big difference between according to the other types. And metadata could be almost unlimited, as we can see later. And it has a unique identifier. And another typical thing is that it doesn't have any hierarchy, which might be a plus or a minus depending on your needs. And usually it is used when you have to deal with large amounts of unstructured data. as everything in this world, it has some positive and negative features. And starting with the positives, it's much easier to be scaled comparing to the other types. And yeah, metadata possibilities are almost unlimited. You'll see later on the demo. Usually it has a lower cost than the other storage types, and it's pretty easy to use. But on the other hand, as a negatives, it is much slower. Sometimes it could be similar depending on implementation, but usually it has higher latency and a little bit slower performance. It's again unstructured, which might be a problem, and it requires a special code in comparison to the other types, which usually have already drivers included in most operating systems and much more ready to use. Let's talk about our implementation of object storage in CloudStack. It's incoming in the next release 4.19, as mentioned in Abhishek's presentation yesterday. And currently, this is phase 1 of the project, so it supports only one provider, which is Min.io. And if you don't know, that is an open source implementation of Amazon S3 buckets. Also, by the way, it also has simulator as providing the way to just to test the functionality without actually having any kind of object storage. Of course, it's limited to some extent. I can show that later. And we could easily add another S3 compliant object storage providers in future because architecture is similar. And initially, we created this without UI functionalities about dealing with buckets, but it felt like somehow incomplete. So we decided to make a step further and implement this as well. So now it has a UI browser that you can manage the objects inside the buckets. I'll show that later as well. And another important thing is only root admin is allowed to add and manage the object storages. It's part of the infrastructure screen in CloudStack. And user and domain admins can only deal with buckets and can create and destroy their own buckets. By the way, the root admin is able to manage all the buckets, even the user-created ones. So we might change that in future, depending on what is the feedback of community. And finally, it's important to mention that the CloudStack doesn't deal with the underlying object provider software, so everything related to security, backing up, or multi-site replication, it's not part of CloudStack. It's the role of the object provider itself. About the future, we could add, of course, we should add more object storage provider. The first candidate being Ceph, and one day maybe it could be used for secondary storage and maybe even replace the current ones. And perhaps we can add functionality to use this storage for backups. The supported bucket features are the regular one, so we can set a bucket quota. And it should be mentioned here that the bucket quota for Min.io in our current implementation, it's not really the best. So it takes some time until the object provider realizes that the quota is already reached. So in some cases, it could take minutes before realizing that, and that means that you can upload more than the quota, which is not the best, but it's not a CloudStack problem. It's just min.io limitation for now. We support encryption. If, of course, if the server has been installed with encryption support, and versioning of the objects in the buckets, so you can upload several different versions of the same file and choose older version if you need to. Object locking is another supported feature, which is you can upload some object in the storage, and it's usually warm principle, means write once, read many. So it could not be touched once it's uploaded, but of course everybody can read this file. And on the final point, we have two different bucket policies, which is the standard security, I would say, feature for buckets. And the default one, if you don't set anything by default, of course, it's private bucket. So even if you provide a link to someone else, they won't be able to see it without proper authentication. But if you set it as public, it's just readable for anyone that has the link. And here is the demo. By the way, this was AI-generated image of CloudStack orangutan. Okay, so here is the new member of the infrastructure screen, object storage. As you can see, we have two of them. This one is a simulator, which is like a fake one. It could be used for some kind of automatic smoke testing, or just a quick test of the features. But it's important to mention here that it doesn't support UI browser because it cannot hold any objects, obviously, because it's a fake provider. And this one is the real one. And you need a URL. I'll show you how you can add a new one, but we won't do that right now. So you need to provide a URL and access and secret keys, and of course some kind of name. And then you can just go to storage section, and then you have this new buckets screen. Here we have one bucket with some files inside. And this is how it looks like. You have all the important information on this page, like size, URL, and secret access key if you want to provide that for someone else to use it. Here is the UI browser. and we have some files already uploaded here. And this is the upload dialog. You can see that you have multiple selection here, so you can choose more than one file. And you can add metadata as key value pairs as much as you want. That's the most important benefit of using object storage and buckets. It's a little bit hard to do this, but yeah, I'll manage. Okay, so we have the objects already uploaded. And if you look at the file, you can see the metadata we have added there. And as a key and value pair, and we have two links. One is the regular link, and we even have already prepared a pre-signed URL containing the authentication for this. Since it's a private bucket, you won't be able to use only the link without authentications. Let's try this. I think it was private, but now we'll see if that's the... Come on. Okay, this actually works. So the bucket is in public mode, and no, sorry, it's access denied. So yeah, it's private, and you need to authenticate in order to get the actual file. But yeah, I forgot to show you the other link. So if you look at the pre-signed URL, you can see the difference. No. So you can see in the URL that we now have authentication included in it, so the file is actually downloaded. And I'll just show you how to change that if you need. So you have modify bucket button here. And you have bucket policy, and if you decide to make it public, you can work with the regular link without authentication. Click. Yeah. Oh. No. It's okay, yeah. Okay, so I believe that's most of it, and the adding new bucket is pretty easy. You just need to select a name and some kind of quota if you want to, and encryption, versioning, object lock, and bucket policy. Let's just create this one. It's brand new, and here you can see the size is still 0. That's another thing I should mention. Sometimes it's kind of slow updating the size, so if you upload some files, you won't see immediately this shown in the UI, which is again limitation of min.io. So yeah, CloudStack just uses the underlying provider, and it's all dependent on what it is doing. Okay, I think I covered everything. Yeah, and just one more thing I wanted to show you. This is the min.io console that flicked for a bit. And you can see the buckets here being created in the same way as in CloudStack. We need to refresh. Oh, in simulate, okay, yeah. So we won't see this one, but we see the other one here with the usage and how many objects and everything. So it passes all the information properly. And yeah, that's it. Any questions?
Thank you.
Vladi, are you tracking any usage? CloudStack is tracking any usage for this?
Oh, sorry, that's too much, isn't it? Yeah.
Yes, the usage server is counting all the important things like how many data is in the buckets. So yeah, it's working as expected.
What are the actual use of this object storage? Is it object storage provided for the virtual machines used in CloudStack, or for CloudStack services for the cloud itself or the cloud users, like the virtual machines?
Yeah, actually, currently, object storage cannot be used in CloudStack. It's just a UI interface. It's like a side thing to CloudStack. You cannot use it as primary or secondary storage or for VMs. It's just another way to store some files or objects. Yes, probably.
So when you create a new bucket, for example, and you can provide it for the users, and in the virtual machine you can use this bucket to store objects in it. Is that correct?
Not yet. This is the first phase, and unfortunately CloudStack cannot really use this object storage as a storage.
No, I mean the virtual machines, the applications.
Oh, yes, yeah.
Can use this.
Of course, yeah. I mean,
and they will use the CloudStack endpoint to send objects and to retrieve objects, not the backing object storage.
Actually, no. You just should provide the link to the VM, the link I showed you. So
but this is the link in the CloudStack.
Yes, but
the CloudStack controller.
CloudStack is not the gateway, just exclusive. So you have to talk to the object storage gateway.
Okay. Thank you.
Any more questions for Vladi from the room?
So looking at the storage, it seems like it's not built for multi-tenancy at the moment because you're using a single access and secret key for the object storage. That means that if we would want to expand this to having users access the storage, they would all be using the same access key within the storage provider, correct?
no, there is...
Account level, every account can have their own. Sorry, so every account can have their own buckets. Buckets are owned by account. Like in CloudStack, every resource is owned by an account.
Yeah, but on the storage side perspective, when you add the storage, you give it an access and a secret key.
Only the admin does that. So two parts. The object storage pools are added by the CloudStack admin. That's the Minayo. Accounts have ability to self-service, and when they create a bucket, it's owned by that account. So if there's an account Vido and Rohit, Vido can access his bucket, Rohit can access his own bucket.
Okay, let's talk about the one, because I think there's a small glitch in here. But I also promised that I would write a Ceph integration, because looking at the code, I looked at the code this morning and I was like, yeah, that's doable. So I'll write that.
That would be awesome. It's a promise, right? And that's on record, Vido.
It actually answers the question online. Will this work with Ceph? In a couple of months.
Okay,
Thank
we
you,
have a
Vido.
promise.
We've got a few more minutes. Any more questions for Vladi? Great. Vladi, thank you very much.
Thanks.